Hello everybody, today is episode 1 of Learn ComputerCraft. Throughout these tutorial series, I'm going to be going over basically how to use ComputerCraft, not necessarily the mod, and I'll get into why that is later. I'm going to be teaching you how to create Lua for use in ComputerCraft. Now, Lua in ComputerCraft is slightly different to Lua default, like Lua interpreter, like if you were to do Lua through your CMD, mainly because certain aspects of the Lua language are sandboxed and or removed for security, and certain APIs are loaded Java side or just normally loaded like FS that add abilities that are not available in default Lua that would have to be created manually. For instance, like I said, the FS API is very helpful for exploring directories and finding files. This isn't really possible in default Lua, as the only API you have for interfacing with the file system is I/O. So now that I've gotten that out of the way, let's get into it. So first of all, I'm going to be programming Lua in a text editor. I'm not going to be using the game. Minecraft is very rarely going to be run in the first few episodes of this. The only time I'm going to go into Minecraft is when I have to physically interface with like a peripheral, like redstone or a modem or something like that. It can be done using the emulator, but it's easier just to actually physically place it. So when we get to that, we will move over to physical ComputerCraft, and I'll show you how to do that. For now, though, I'm going to be using an emulator. So the link to this emulator will be in the description. If you really want to, you could type it from here, but you'd be crazy. It's called CCMU Redux. It's on the ComputerCraft forums, and it's great. So go ahead and just download it from here, and once you have that, you can just run it. Might as well close this. So we've got ComputerCraft MU Redux opening up. Now I'm going to start a session. I'm going to create a new, think of this as making a new world, and I'm just going to call this YouTube, so why not. I'm going to create this session, and I'm going to load into that session. So now you have this blank screen. If you mouse over to the top left and click this menu icon, and then click Open Computer, type in the ID as whatever you want. I'm going to keep it as 0 for simplicity's sake. Then click Next. Make sure the advanced button is not checked, and then we'll just call, I don't know, whatever. Call it whatever you want. It really doesn't matter. Now we have this computer. Those of you that are already kind of familiar with the ComputerCraft mod know that there are actually three types of computers, 2 available to survival players and 1 available for ops in creative mode, which is a command computer, which is literally a command block that can be programmed in Lua. So this is a default computer. This does not have access to colors, does not have access to mouse click events. So if you want to make a program that uses the mouse so you can click buttons, you cannot do it on this kind of computer. We're going to get into that later. Very easy to upgrade in the emulator, a bit more difficult in the game because you have to physically make a new computer and you'll have to transfer your code over. So firstly, what are we looking at? This is the terminal. So you see we're running CraftOS 1.7. Again, version doesn't really matter. We're not going to be doing anything that's version dependent until we get into advanced GUIs, in which case we will, but there will be backdrops for that so that it supports older versions of ComputerCraft. And like I said, I'm not going to be programming in the game, and this includes the emulator. I truly hate the in-game editing system, so we've now created this computer, so I'm going to go Windows key R and go to my application data, which is %appdata%, as you can see in the lower left there. I'm going to go to this location by clicking OK, and you'll see that I have a folder here called .ccmu Redux. Go ahead and open that, then go into Sessions and the session name that you created, then go Computer, and you should see 0.json. Now, sometimes there will be a 0 folder here. This is only going to be created once you create a file in the computer. So to go ahead and do that ahead of time, we're just going to create a folder and we're just going to name it 0. You should name it whatever this JSON file is named, or just the name of this computer. Everything that you write by going, edit file, you'll see is in here. This file called file. If you type file, it runs our file. I'm going to get into what it is I just wrote there, but I'm just going to show you that this is where all your things are going to be stored. So, considering that this is where we're going to be programming, I'm going to open Atom in here. Okay, so now we have this empty 0 folder, no files in here, and we can create new files, whatever. So now that we have Atom, we can start. So one of the first things you should know with ComputerCraft is that if you have a file called startup, like that, on the computer. It will run when the computer starts up. It is like your boot drive. Let's create a startup file and just see what happens. I'm going to go new file, startup. You can do this another way by going edit startup. It does the same thing, exact same thing. However, you won't have to type your code in there. I'm also going to set the syntax highlighting on Atom to Lua. As I do this, I'm going to press Ctrl-Shift-L. If that shortcut key doesn't work, or you're on a Mac or Linux or whatever, I don't know anything about Linux in terms of keyboard layouts. And you can go down to the bottom right where it says plain text. Go ahead and click that and it will open the same menu. I'm going to type Lua. Chances are you will not see Lua in this list, so I'm going to go ahead and show you how to install Lua. So I just press Control comma. Again, if you can't do that, go File and Settings. I then went to Install in this tab and just typed in Language Lua. I'm going to take a second, but the first option here is Language-Lua. Add syntax highlighting and snippets to files in Atom. Install this. I already have it installed. Make sure it's enabled. Reboot Atom just to make sure no funny business happens. You will now have Lua available. Lua will automatically be selected when a file ends in the extension .lua, also known as Lua. Of course, this does not have a file extension, so you will have to manually set the Lua syntax, most likely every time you open this file. Let's get into it. First thing you probably want to do is output something to the screen. Might be, might not. I'm going to go ahead and assume it is. So there are 3 ways you can do this. As a matter of fact, there are 4. We'll go into the 4th later on in our GUI section. The first and easiest way is the print command, literally type print. Now you'll be noticing I'm putting some funny braces after this. Now what are these? These are parentheses. And this marks that this is a function and I want to execute it. If I was to just type print, it would probably give you a syntax error because it does not know what you want to do with that. As you can see, it's thinking, okay, you want to assign a value to the word print. Where's your equals symbol? There isn't one because I'm not trying to do that. I'm actually being an idiot and forgetting my syntax. So you can do this, or if you're just typing one string, you can actually just put the string there. This does not work with everything. It does work with tables, it does work with strings. It will not work with a variable that contains a string. We'll get into that later. It has to be the raw set variable, literally as if you were typing it in here, but without the parentheses will work. I'm going to keep the parentheses for simplicity's sake. When we get a little more advanced, you'll see that they kind of disappear. So I'm going to print there the normal thing any programmer would do, hello world. And I'm going to reboot the computer, and you'll see it prints hello world. Fantastic. End of episode. No. So what are the other ways? Term.write. Basically, as far as you're concerned, term.write accesses the window, just your computer. You can then go hello world. There is a problem with this though. You can see that the cursor stays on the same level rather than jumping down here like it did before. And also, if the text is too long, it will not word wrap. As you can see, it doesn't word wrap. You don't have the O coming down here. It just moves the cursor down, right? However, write, on the other hand, does not do that. This is the 3rd and final method I'm going to be telling you. This one will word wrap, as you can see. Pretty cool, right? So don't worry about the string.rep thing. If you don't get it, it's fine. We will be going over it in much more detail when we go into string meta methods and again advanced GUIs, which is something I am planning on covering. So those are your 3 main methods for writing things to the screen, right? If statements. What are they? Why are they useful? How the hell do I use them? If statements are tremendously helpful. It allows you to perform logic in a program. An example is a password lock. You want the user to enter a password. So I'm going to go local input equals read. Why did I make it local? Well, you're going to be entering a password. If I don't make this local, after the program's ended, I can go into a thing called the Lua prompt. And if I type in the word input, it will contain what the user typed. However, if I make it local, then it is only available to the program. Only code in startup can access that variable. Anything else cannot. So local input equals read. I'm also going to put a asterisk in here. encapsulated in quotation marks. What this means, the quotation mark means it's a string, the asterisk is the character in which will be placed. So you want to enter a password, right? But you don't want people to see what the password is you're entering. What this will do is replace every letter you type with an asterisk, making it start out. So now we can just do if input equals my password, then else, right? So if input equals, and you're probably like, typo. You've got two equal signs there. Not a typo, on purpose. Equals equals, or equal to, is a comparison. So if input is the same as my password, up here I have one equal sign, which is setting input, the variable in the local environment, to whatever read returns. And again, read has parentheses, it means it's a function. It will prompt the user for an input and return whatever it is they typed after they press the enter key. And then I'm doing if input is equal to, this is a comparison operator, this is an assignment operator. If input equals my password, then print correct. Otherwise, I'm going to print incorrect. Let's see what happens, right? Let's have a look. Still running. If I type in my password, you'll notice that there it is. It's starred out, as you see. This is what this is doing. This is asking the user for input and starring it out. When we press enter, read is going to return what we've typed, which is my password, and it's going to go if what you typed equals my password, which it will. It's going to print correct, as you see there. Now we get this little angle bracket back. We are back in the shell. We can use ComputerCraft again. Whereas there, we were limited to typing something and having it compared. We didn't have access to any commands. If we reboot again and type something else, incorrect, right? Awesome. There's your password. This is what most password locks consist of. Very easy to bypass, however. If you just press and hold Control-T, you'll notice that it comes up saying terminated. Of course, again, there are ways of stopping this. So, let's get into variable types. There are 3 variables that I'm going to cover now, and there are another couple that I'm going to cover in the next episode. The 3 I'm going to be covering now are strings, numbers, and booleans. These are the 3 that you probably use most of the time. So strings, let's say I make a variable called myString. A string is normally encapsulated in like double quotes. You can also do single quotes, or if you want a multi-line string, which we'll get into some other time, but just so you know, multi-line strings are with these kind of brackets, and this is all string in here. So this is a string. We've seen this one before when we did the if statement with the password. My number is like 1, 2, 3, 4. You can also have 1 decimal point in there. Like 1, 2, 3, 4.3. 5.3.3 is an invalid number. It's got multiple points, not a valid number. It can't have that. It will actually crash with a message saying multiple points. It doesn't give you a line number, which is very helpful when debugging. No line number. So just watch out for that one. It caught me off guard when I was doing numbers for like versions of a program. So you can't really do that. The only real way of doing that was with the string. So yeah. And then my boolean. Booleans are a very cool one. You have true or you have false. I'm going to put in comment false here. You can only have true or false. A boolean is one of 2 types. It's either true or either false. So if I do if my boolean, then print true or whatever, then it will fail if the value is false. Whereas if I set the value of this string to false, that's still a value, so it will still go through the if statement. So if I do if my string, then print true, this will print true, even though it says false, right? What the hell? If I do my boolean though, and I change this to false, there are no capitals, it has to be exactly that, then it won't print, because that is false. Even though it does have a value, the value is false. Very helpful in a lot of ways. So you've got strings, numbers, pretty straightforward. It's just a number, right? You can have up to 1 decimal point in it. My boolean, true or false, nothing else. That will do it for this episode.